Hi, my name is Yulia Startsev. I am a developer on SpiderMonkey, the compiler for JavaScript and WebAssembly. I don't work on the WebAssembly part, but JavaScript WebAssembly for Firefox. And this stream is going to be all about JavaScript, the specification, and getting fixing bugs in SpiderMonkey related to the specification or implementing new features, understanding the JavaScript spec and how it works, and how you can get involved if you want to fix a bug on Firefox or see how the engine works or something like that. There are several links in my description, so if you want to get involved, there's this interesting... I'm a little nervous. It's my first stream. We've got a service that helps beginners get paired up with mentors, and the name is escaping me at the moment, but it's really great. It's in the links that I have on Twitch. It's a little slow. So I've got resources here, and it says, if you want to find your first bug, it's called Code Tribute. So check that out. And there are several other resources available if you want to learn more about how to build SpiderMonkey or about the language specification or about the test suite we're going to be looking at. That stuff's all available. So I'm going to be streaming today for exactly 1 hour to see how this works. And today's stream is going to be all about fixing a small bug in the implementation of our JavaScript engine. And yeah, and we're going to see how that goes. And next week is going to be a little different. We're going to look at something else, specifically because next week is TC39, Technical Committee 39, where the committee comes together, the people who design and specify JavaScript come together and design JavaScript and talk about it. And we can do a Q&A session for an hour and see how that goes. And if people like that, that's something else we can do. And then there will be a third session a week after that. So next week on Friday is the TC39 Q&A session. And then the week after that is going to be, once again, a bug fixing session. And we'll see how that goes again. So without further ado, I'm going to go ahead and get started. I'm going to probably talk pretty solid for about 15-20 minutes, where we're going to go over the problem and the spec. I'm going to take a break for questions. So I'm not going to be looking at the Twitch stream all the time. So if you ask something, I might not be able to react right away. But then I'll take a break and I'll check out your questions. And then I'll go back and we'll implement the fix and get it running. And after that, there'll be another Q&A session where we can talk about what happened, any questions you have, and I'll try to make it as, oh, this is supposed to be a different thing. See, first stream, I don't know what I'm doing yet. We're going to have a chance to talk and debrief and see how things went. There's also a suggestions box that you can check out on the channel. So if you have suggestions for what I could do better, then please let me know. The terror is real. Okay, let's start with talking about a problem. Now, what I'm looking at here is this really great site. It's called Test 262 Report. Let's just take a look at what the regular thing looks like. And what this shows us is the conformance of all the different engines that implement the ECMA 262 specification. And oh, someone says I might have forgotten to set the title and category. Yes, I might have. I have no idea what I'm doing with Twitch yet. So to come back to what we're looking at here, Test 262 is a test suite that tests conformance with ECMAScript, which is the specification, ooh, I went a little too far, for JavaScript, which is specified by TC39. And just to come back to that specification document, this is the specification for the language. This is the thing that tells us what JavaScript is. And what we can think of as a specification is like, you can think of it as this piece of paper I've got. Yeah, that's fine. This piece of paper I've got, which is, the contract between the users, the programmers who are using the language, and the people implementing the language. Like, this is the thing that should be consistent across all implementations. And it shouldn't matter what implementation you have. Like, you can have this implementation, or you can have that implementation, and they both have the same wrapper, the same interface layer, the same contract with users. What we're going to do today is we're going to look at one of these implementations, and we're going to take a look at a test that's showing us that something's not quite right. And we'll go in and we'll improve the conformance to the spec. And the way that the test writers do this is what they do is they look at the language and try to find ways to expose certain areas where, like, normally you wouldn't think that that's inconsistent with the language, but it is inconsistent, and you can show that through the tests. So we're actually going to use the surface. We're going to use the surface of the language to expose problems with the underlying implementation. So, getting back to our reports, here I'm looking into the test suite for the language. And under language syntax, under expressions, we've got this thing called prefix increment. Now, you might be familiar with increment and decrement. Let me show you an example. I've got a thing right here. So let's say you've got, A is a number, and you can either increment it this way, and this will be 2, or you can increment it this way. This will, well, and now it'll be 3. But you get the idea. That's what an increment, or what a prefix increment is, and what a postfix increment is. And here we are looking at the prefix version of this. So we're not looking at this one. We're looking at this one in particular. And what you can see here is that our conformance from SpiderMonkey is at 89%. So that's showing us that, well, we're actually failing a little bit in terms of we're failing a test. Let's take a look at one of those tests that we're failing. I think I've got it right here. Oh no, that's the whole spec. Okay, here we are, some failures. Let's take this one. Okay, and let's read the test and try to understand what the test is trying to tell us about the expected behavior, and then find out what kind of behavior we have, in fact, on our end. Okay, so this is written by Andre Bargul. He's an amazing contributor. He also helps us a lot with our implementation. And he's written a really helpful comment here that says, pose a prefix increment of x, I'm just reading along here, evaluates its reference expression once. Okay, that's really, oh, you can't see the test. I'm so sorry. Totally sorry. Okay, now you should be able to see it. So I'm looking at a prefix increment of x evaluates its reference expression once. And then there's a description here. The operand expression is evaluated exactly once. Operand expression is the member expression, and then a colon, base, and then brackets, prop. Base is the undefined value. And then we've got a test here that should tell us something about what's going on. So they're creating a function dummy error, and they're asserting that it should be equal to when we call this. When we try to increment base and then call prop as a function. Now, probably you would never do this in JavaScript code, but what this is doing is making us look at the language and say, okay, there's something inconsistent about accessing on the base when we've got an increment. It's telling us that this should be the same as without the prefix. Let me show you what it looks like, and then we can it'll make more sense. And maybe I'll take a short break so that we can get some questions in. Okay, so back to programming. I will get the hang of this eventually. Okay, so what I have here is actually, I have a running shell, a working shell that we can play around with. And let's run it. How about I clean that up? Okay, so if I do plus, let's say we have a var a equals 1. We should be able to do this, and that should be 2. And that makes sense. And what this is telling us is something's not quite right. So let's just try to do an object. I'll use var for now. And it's a number. Everything, this is like the happy path. Everything works. And we should be able to do, and that should work. And this should work. And, yeah. Well, that's because I don't know how to type JavaScript anymore. That should work. We're accessing it as a property. We're accessing it as an element. Everything looks as it should. OK, so let's say we're going to make this a little more complicated, and we're going to do function break stuff. And we're going to throw an error. Now, let's take another look at that test. And in this test, what it says is we should assert that this function throws with this dummy error. Like, we're expecting a very specific error to happen when we do this. So let's switch back to the code. And arguably, we should also be able to not break stuff. Let's first see the happy path, happy stuff. And here we're going to return the valid thing. There we go. And we should be able to do that works. We're super happy. And let's go back to this one and just make sure that I'm doing the same thing here. Oh, right, throw, return. Oh no, and I just turned off my laptop. Okay, this is right the first time. Panic. Okay, now let's do the break step. Okay, did that wrong. Cool, and we've actually got an error there, so that's working perfectly. We're happy with that, but let's look at that test again, and let's really pay attention to what it's saying. It's saying that base should be undefined, and we should throw an error here. So let's try that again, this time with an undefined value. So now we're going to go var base, just like in the test. And what we're going to do is ++ base break stuff. OK, cool. And we're getting an error there, right? But let's take a look at what that test actually said. The test was telling us we should be getting a dummy error. The error that we're getting is base is undefined. We're not supposed to get that. So reading the test, we kind of get this suggestion that what's happening is, well, its reference expression should be evaluated once. So it's kind of suggesting that we're evaluating twice. But is that really what's happening? So let's see if we can say, like, maybe we're evaluating twice, maybe something's getting evaluated in the wrong order. OK, let's see if we're evaluating stuff twice. Let's go back to our object that we defined earlier. And instead of a being just a simple value, let's make it a getter. Let's call this object 2. And in SpiderMonkey, you can do print instead of console log. There are some like small differences between implementations. OK, so I added a print statement. And if we get this, and like, regardless of if it throws an error or not, if it's being accessed twice, if the expression is being evaluated twice, we should get print hi twice. Oh, I broke something. Oh, I did break something. It's supposed to have another one of those. OK, I missed a curly brace, in case anybody missed that. OK, let's increment a. Wait, wrong object. OK, cool. But check it out. We're only evaluating once because we're only getting that printed once. So, and actually, let's be more precise here and actually do it like this. We can even create a function. And this should all work exactly the same. So we're not evaluating twice. So what's actually going on? What we want to do now is we want to look into the code and try to figure out what might be happening. What's going on strange? And I'm just going to pause here and check with all of you folks who are watching if this made sense or if you've got questions. Okay, it doesn't look like there are any questions yet, but I hope it's clear that what we're looking at is that when we do base, which is our undefined value, and we call, I should have shown this, break stuff. Check this out. Right now, break stuff is undefined? Yes, it's undefined because of capitalization. There we go. When I do this, we get a different output. We have an undefined error because I didn't name the error from this, where now suddenly because we're incrementing, the base is undefined. All right, let's see. Any questions? What's the difference between the prefix, the plus a and a plus plus? I don't think that there's really any real difference, even when we have the implementation. It's just whether or not you want to put it before or after the variable. The implementation is pretty consistent between those two. So, yes, I will upload after. It is actually I don't know about the C implementation myself, so I can't answer that question. But it might be like in C. Okay. So yeah, what we're doing here is actually we're just making sure that this case is the same as, that this case and this case are the same. And they're not right now, and that's a problem. Okay, I'll let you folks discuss what the difference is between a postfix and prefix increment that I don't know the answer to. And I will go ahead and show you our implementation of this part. Okay, so actually, I have everything open already because I was checking it before I did this stream to make sure I had all my materials. Okay, so here we are. Actually, I'm going to quit this all. Here we are inside of the Mozilla Central Repository. If you clone it for yourself, you'll get the exact same thing that we're looking at now. And I use Vim, just because I got used to it. And here I'm looking at the JS directory, which is where all the code we're interested in lives, mostly under source. We write most of the code in C++. It's a new language for me, actually. I come from a JavaScript application background, so I've been learning C++. So if you feel like, oh, you're a JavaScript developer, maybe C++ is going to be difficult, it's not that hard in the end. There are some things to get used to, but it's fine. And so going back to the tour, we're going to be looking primarily at this front-end folder. There's lots of files in here. And the thing that I want to show you is a really specific file, which is the bytecode emitter. It's the wrong file. The bytecode emitter is the part that emits the instructions to the interpreter. So if you've read a little bit about parsers or you're familiar with parsers, you might know that there's several parts to a parser. So to a compiler, to an interpreter, to anything that takes one language and translates it into another, you might have the lexer or tokenizer. It might be too big. That's too big, isn't it? I'm going to make that a bit smaller so that it's easier to read and I can write more easily. Okay. You get the idea. It looks very messy. Sorry about that. Then that might be transformed into an AST. And then what happens next is sometimes you take that AST and you start implementing the behavior of the AST, because on this layer, we're talking about syntax. And I really can't spell. Yeah. syntax. You get the idea. And then the next part, ooh, oh no, this is getting all funny. You can even see where I drew a line. From the AST, we have the layer where we start thinking about what does this mean? What's the meaning here? And that's where we get into the bytecode. In our implementation, it's the bytecode emitter. So from a spec perspective, let's get rid of all of this. I wonder if I can clear this more quickly. I haven't practiced enough, clearly. So in the spec, you have syntax. There's a little bit of lag with the pen input. And semantics. And the difference between these two things is the syntax is the form, like what is the shape of the code. So in our case, we're looking at plus a, and the semantics of that, the meaning of that is add 1 to a. So that's what we're trying to do. And since the problem, it's not with the parsing of the pre-increment to the variable. It's with the meaning that the engine is getting out of it. Something is different between just accessing that element and incrementing it. Oh, I'm going to show this in a slightly different way because we can do something really cool with this. I have a test file ready to go to show you what this is. And nervousness makes you forget all about your plans. So I have this special file that I prepared, and what it is I don't think that this foobar thing is important anymore. Yeah, that's not important. What this is it's the basic case that's in the test. And you'll notice that there's a special function called dis, and that allows us to do disassembly into bytecode. Am I muted? Can people hear me? Okay, cool. So I just showed you that there's a way to see the disassembly, the bytecode that gets output. Let's see what that looks like by running that file. Okay. So what we have here is a lot of information that's just been spit out at us, and it can be really daunting to understand what this all means. So let's walk through it and just try to take it apart. I'll tell you where not to pay too much attention, and then we'll see what this looks like in the code that generates it. So this beginning part we're going to ignore, because what it does is it sets up the disassembly algorithm that actually spits all this out. The next thing that happens, we're binding a name base to undefined, and then we set it to that name. So we can just read this stuff out. Then we pop, and we'll look at what that means in a second. Then we bind a name prop to a lambda function, and then we set it to that. Next, we get the base. Then we check if the object is coercible. That's an interesting instruction. Then we get the prop. We do something implicit this with the prop. We're not going to pay too much attention to this yet. We call it toID. Lots of things that are, really confusing. What do these all do? Well, let's figure out how to learn about them. So what we're going to do is we're going to go to bytecode descriptions. This is all online, and what we can do is any one of these that we're confused about, we can look it up. So for example, let's look up get element, and here we have a description of what that bytecode does. Or, for example, we can take a look at the one that I noticed that's sticking out to me, which is check coercible. And this gives us a little bit of information. It tells us that it implements require object coercible. And it gives us a little bit of information about that. And this links out to the spec. So here we get to do a little bit of spec reading. And before I get into this, I'm just going to check if there are any other questions. Feel free to ask them as I'm talking, and I'll roll back whenever there's anything that needs to be addressed. I don't see any questions in the chat right now. If it happens, I'll be checking regularly to make sure that I don't miss anything. Okay, cool. So we've got this thing, require object coercible. If you're coming from a JavaScript perspective, it might be like, oh, you know, this kind of looks like a function. And when we read this, I'll just read it out loud. Oh. Someone asks, maybe I missed it, but is this assembly language some kind of representation of the SpiderMonkey engine or some standard way to represent assembly? Does V8 have a different one? So it is SpiderMonkey specific. It's internal. It's something that our interpreter reads and other parts of the engine read that. Okay. So this function-like thing, we have a table here of the results that can happen. So it takes an argument, and it throws an error if the argument is a value that cannot be converted to an object using toObject. Now, if we click this, it's going to take us to toObject and tell us what does it tell us? It converts the argument into a type of object according to this table. So we can read this table and then figure out what that should return. We're going to skip this part because it's not super important to us right now. What this tells us is if it's undefined or null, it'll throw a type error, which is what should be happening in our representation, in our implementation, and that's not happening right now. The next question I have is like, well, what should be happening according to the spec? How do we read the spec, and how do we find out what should happen? So I'm going to look at, can I find it this way? Yes, prefix increment operator. So here we have a nice small piece of specification. And what it tells us, this first part, well, this is the semantics, but this is also the syntax. So this is with two pluses in front and then a unary expression. So what is a unary expression, right? And we're going to be evaluating that unary expression. So this line is important. This tells us that this is what we're going to be focused on. What is this unary expression? So if we click on it, what we find is we get this syntax section that's currently being covered up. This syntax is defining what a unary expression is. You can think of a unary expression as something similar to a regular expression with variable names that are being defined. And we can read this as, what I do is I read the colon as is a. And let's just read it out loud. A unary expression is a update expression or, so I read the line break as an or, update expression or a delete unary expression or a void unary expression or a type of unary expression, etc. So when we're looking at this, what we can do is, because Ian's on the stream, I totally have his props on here, you can think of it as a series of plugs, things that can fit into the definition of that thing. And those things each have their own plugs, assuming I can plug things, that have their own set of things that you can plug stuff in. And eventually, you keep plugging until you get to something that can no longer go any further, like a punctuation or something else. So what these are called, these parts that are intermediary are non-terminals, and these ending things are terminals. In case you ever wanted to know how to read grammars. Just imagine that the grammars are just really bad cable work, and that's what parsing is. And in fact, if we want, we can just keep clicking through this We've got an update expression is a left-hand side expression. Well, what is that? We click on that. A left-hand side expression is a new expression or a call expression or a optional expression. We can click on new expression. A new expression is a member expression or a new expression. We click on member expression. A member expression is a primary expression or a member expression with the brackets. That's important. We're going to be looking at that in a second, that it has an expression inside. Or it is a member expression separated by a period, followed by an identifier name. Or it is a member expression with a template literal, or a super property, or a meta property, or a new member expression. Let's keep digging down. Primary expression can be this. It can be an identifier reference. Again, we're just going to take the first top thing. An identifier reference can be an identifier or a yield or an await. An identifier is an identifier name, but not a reserved word. An identifier name is an identifier start. These hovers are annoying. Stop it. Or it's an identifier name followed by an identifier part. Okay, and you'll notice that these are recursive. So identifier name refers to itself, which can be an identifier start. Or it can be an identifier name and an identifier part. And an identifier start can be a number sign or a Unicode ID start or an underscore. And a identifier part can be those things. And then you can dig further down to this can be any Unicode code point. And that's where we get to the end. So let's back up a bit. You can get really lost in the spec. And I noticed that there are some questions. Right. The expectation that there's a little bit of overlap between JSC and SpiderMonkey assembly code. The assembly code, like when you get all the way down, there probably is, like, because you're compiling down from different architectures. But the bytecode isn't the same as assembly. And I'm not sure if that's what people are thinking, but the bytecode is really an internal representation, a simplified version of the behavior that's easy for us to work with inside of the engine. Okay, coming back to our goal, which is to understand what's broken about our property access when we're doing an increment. So let's just review what the problem is. Oh, that's the wrong thing. Okay, so let's take a look at that funny file, this foo.js, eventually, when it loads. I don't know why it's been so slow recently. It's only been doing this today. Okay, so actually, I'm going to exit that. Quit. Oops. Oh, no, don't do that. Whatever. Okay, so let's take a look at foo.js. Yeah, it might be too many plugins. That's true. Really takes a while to load. Okay, so let's take a look at this. What can I do here? How can I do this? No, stop it. Okay. So if we take this away, we take away the increment decrement, and we run the code, we're going to get a dump of, oh no, I broke my terminal a little bit. I'm just going to start a new one. Okay. And let's run this. But I'm going to modify foo to be slightly different again, eventually. And for now, I'm just going to scroll up so that we can see this more clearly. Okay. We're not interested in certain things, so I'm just going to start from the point that we're interested in. No, work correctly, damn it. just go from here all the way down to here. That's what we're interested in. Yeah, it doesn't matter what the extension is. Is that how you do it? Oh, does anybody know how to set... this is going to take me just a second. And this is the check object coercible one. Oh no, I'm stuck between everything. There we go. Set text wrap, thank you. Oh, no, it's not. Set no wrap. No. There, thank you, all of you. You're the best. Okay, so that was with the increment, and what I want to do is without the increment. Oh no. Okay, and I'm just going to pull this into Vim so that we can look at it a little bit more closely. There we go. Cool. So the first thing that we're going to notice here is that we've got two things that are happening that are different. So these first couple of lines up to here are all exactly the same. And what is this all doing? We're operating on some kind of data structure. What we're operating on, and I had ordered props, but they never arrived because we are in very special times. So what we have are a series of objects being pushed onto a stack. And the bytecode itself isn't a stack. It's a series of instructions that operates on that stack of values. So let's say that we're looking at this first set of things. Well, ideally, I had this plan for a different part. Ideally, like you put the object, in the ideal case, you have the object on there. Then you push onto it the element you want to access, which happens to be a function. Then you say that, oh, actually evaluate this function, like we saw in the, let's take a look at the spec view again. Forgot my whole spiel that I was going to do. So we're reading the spec right now. And here in this section about the grammar, we have the instructions for evaluating this piece, which is exactly what we want to evaluate. Member expression with the square brackets expression. So let's see what that tells us. And we can scroll down in the specification to get to the semantics, the behavior. And we should have, where is it? These are errors. We're not interested in that. Property accessors. We're accessing a property, and here we have the runtime semantics for the evaluation here. And what it tells us is, let's get rid of this. Let the base reference be the result of evaluating the member expression. So our first member expression is the thing that we've got on the stack at first. And let's do this with the code. So, where am I? Okay, so we get the base, we get the value that we want to assign to it, and we set it. Then we get the prop, we get the value we want to assign to it, which is the lambda function, and then we set it. And we pop both of these things off the stack. So first, we're putting undefined onto the stack, and the variable we want to assign to it, the two things. And then we set it, and then we remove both. And we do the same thing for the second evaluation. And now what we're doing is we're getting the base, which is normally an object. so that we're here. Then we're going to check if the object is coercible. This is operating on the stack. Then we're going to get the property that's on there, which happens to be a function. So we call it, and we get a value out of it. I'm just going to replace that. And we set that to a key, which is toID. So that's what's happening. All right. I got too excited about props, and I think they got me confused. All right, enough of the props. Okay, so moving back to the specification, what we have here is saying, let's read what this does. Let the base reference be the result of evaluating member expression. And in our case, that is base, so we should have undefined as a value there. So base value, let me write that down, so that people can follow along. And the next time I do the stream, it's going to be a whole lot better. Okay, so what we did is we have base reference is a pointer somewhere, and we follow that pointer to get a value, which is a base value. The interest of time, I will not pay too much attention to whether or not I'm writing well. So that's an undefined value. And the next thing that the spec tells us to do is around strict, use strict. We're going to ignore that because we don't have use strict in this case. This is an error that's happening regardless of use strict or not. And then it says return question mark evaluate property access with expression key. So the question mark has to do with return completion values, and we're not going to dig into that today. We're going to look at it later. So let's take a look at what evaluate property with expression key does. So what it does is it says let property name. So before we were looking at base as the thing we were interested in, now we're looking at property. And in our case, and the second line, I'm losing all of my things. Second line says let property name value be get key from the property name reference. And in our case, it should be a throwing function. And then the next thing that it says is let BV, BV is the base value, which is here. Let the base value be require, BV is the variable that's being assigned by this require object coercible base value. So then at this point, we should go and check if the object is coercible. Let's take another look at what our code is doing, what our bytecode is doing. So we get the base, then we check object coercible, then we get the prop. And what we see here is we should get the prop first, then get the object coercible. So the thing that we need to do, the thing we need to change is remove this and move it after. And we have to skip all of these steps because this is the evaluation. Because after that, step 4 is to property key, which is what toID does. Okay, let me see if I missed any questions. Okay, I see that my colleagues are actually in the chat, and they're actually answering all of your questions, which is absolutely fantastic. So I'm going to let them field that, which is great. And let's fix this, because we've got 15 minutes left, and we got to fix it. Okay, so finally, we get to touch code programming. Okay, so here we are inside of the bytecode emitter. This is the thing that deals with the toilet paper. And let's go to where this is going to be emitted. So it's going to be an emit inc dec. We have, and in particular, it's going to be element emit I think it's inc dec. Okay, here we are. We have emit, increment, or decrement. The path is the same. And if it's a dot expression, we do one thing. And if it's an element expression, we will do another thing. We are dealing with an element expression, so we're going to look at this function. And here we are. Here's the function we're interested in. And it does a lot of stuff, which can be a little bit overwhelming. But we're just going to read it line by line. So we're getting the property by value. And then super, we're not interested in super, we can ignore that. And then we say that we get this kind, like what type of thing are we trying to do here? Because this function handles both increments and decrements. And after this step, what we do is we create this object, an element operator emitter, which is a special helper to help us deal with element objects. There's often a lot of steps that repeat when we deal with the same types of objects. And all of this is set up for that object. And then we do a couple of other things in here. We have this emit element object and key, which takes the element expression that we're dealing with. This is super Boolean, which we're not really interested in right now, and the element operator emitter. So this is before we emit any bytecode. We haven't emitted anything, but here we're going to emit something. Let's take a look at that. And I actually want the definition for that. Okay, here we are. This is the definition. So again, we're checking for super, ignoring that. And then we dig into what it's actually doing. We prepare for the object, which is something that the element operator emitter is doing on its own. Then we get the expression and emit it. This emit tree is basically like evaluate that thing. Then we do the step prepare for key, and then we emit that key. Now, if we remember the bytecode that we looked at just a moment ago, the problem is happening because we are emitting check object coercible between the object and the key. And we aren't seeing that here. Like we're going directly from this to this. So we go from the object to the key. That means something must be happening in between, and we have to look at the element object emitter in order to find out what. So here we are. And chances are it's going to be in prepare for object, prepare something. What was it? Prepare for key. Because that was being emitted in between. What we see here is we have this if statement that if it's not super and it's an increment or a decrement, then we want to emit check object coercible. That's not what we should be doing according to the spec. We should be doing this after we've emitted the key. So where should we be doing it? Let's go back here. So we emit the object and the key. Those two pieces should be done together. And then we should emit the increment or decrement. So chances are we should move that piece of code into this function here so that we can do that in the right place. Okay, so I'm going to grab that. And here it is. Emit, increment, and decrement. This is the right spot. I think we want to do it here. Let property key be to property key. Actually, I know that we should do it to ID. Yes, here. We should do it here because we need to do it before we call this. Again, this to property key is done by toID. So that's what I was looking for when I was like, we need to do this before toID, and that happens in get, emit get. So that's a little bit of like my knowledge coming out. But as you get more used to the code base, this stuff becomes more obvious. Okay, but we're actually not done here because you'll notice that we've got these comments, like these stack comments. And what they are is they're telling us what's on, you know, the props are coming back, right? The stack. So what's on the stack, it's difficult to keep in mind all the time what's going to be on the stack. So we have comments to help us remember. And what's on the stack right now is this. And if we try to call this on object key, and we have the example that we had before, which is a function is going to come back as being coercible to object. And that's not the thing that we should be testing. We shouldn't be testing the key because, again, let's get the props back. The instructions, the bytecode instructions are actually interested. The documentation is on that page I showed you earlier, but the bytecode instructions are actually interested in the topmost value. They aren't searching through the stack to find the value that they're interested in. They're going to be taking this top one, and right now it's going to take the value. So we actually have to switch these two so that we can check if object is coercible rather than value. That's what we got to change. Let's write a bit of code. This is all the code we're going to write today. It's actually a super small change. I'm going to copy this because I forgot when I was doing the Holy.js talk to add a bang, and things went very wrong. Okay, so swap. Oh. And swap. So what we just did, we had, oh, should be like that. We had it like this. We can't test on this value, so we swapped them. We're checking if this object is coercible, and then we're going to get an answer. And then we swap them back so we can continue with the work we're doing. Okay. Now, theoretically, this should now work. And what I'm going to do is I'm going to first show the old behavior. First by editing the foo.js file. I'm in the wrong directory. And exit one of these. So, and make sure that this is the right code. And now I'm just gonna remind everybody what this looked like. So we have base is undefined, and now I'm gonna build this. And this is gonna take a bit of time. So are there any questions, any comments, any concerns, fears, hopes, dreams, etc.? We can watch the beauty of compiling C code. Arguably, this went more smoothly when I did my test run, but that's okay. Hopes many. Oh, good. It's good to be hopeful, especially in this climate. Suspense. Oh my God, imagine if this doesn't work. I need to get a better situation with drawing, because this is not going so well. I really want to draw, and I want to use physical objects to show ideas because I find they help me learn better. Yes, we can run some tests. That is a very good idea to run some tests. While this is building, I'm going to fix the tests. What is this test called? It is this. I'm just looking at another screen. I'll be right with you. Okay. Well, this is doing it's. Oh, it's done. Would you look at that? Okay. Well, let's see if. So just to remind us, here's the old run, and let's do the new run. Yay! It's a different error. It's super subtle. Check it out. Compare this to this, which is wrong. And this is right. Yay, it works. Let's actually see if it works in the tests, because we do have a test suite, and I just need to find my way through all the... Actually, I don't want to do this. I want to directly get it. JSSRC tests. Test 262. And then, oh no, that's not what I want. Let's grab this. That should work. Oh wait, I don't want that. Why am I looking for that? That's the wrong thing to look for. That is indeed the test, but that's not what I'm interested in. But we can actually just run it, see if it works. theoretically. Mach is our special make for Mozilla. It is German for make. And I think that's it. S. And it should theoretically pass. And if it doesn't, then I've done something very wrong. Well, it says it passes, but I don't know if anything... Oh, it's because it's ignored, I think. Here is where the test is being skipped. And let's no longer skip that test. Okay. There we go, and it passes. 3 minutes left of this stream. All right. What do we do now? How do people normally end these things? Yeah. It is a weird experience to do a stream because all I can do is read the comments and I don't actually get to interact directly with everyone. So I have a special screen for this because I read about how to do streams. What do I plan on exploring in upcoming streams? Well, we will be looking at how the TC39 process works and like what upcoming proposals are and what happened at the previous meeting in the upcoming stream, which is next week, because that'll be just after a TC39 meeting. And this stream for the first 11 episodes is going to be focused on doing very similar things to this. We're going to be walking through the spec, and we're going to be learning how to fix like really small, these are really edge cases of the specification in relation to SpiderMonkey and getting everything in place and working, and basically making SpiderMonkey a more spec compliant implementation. And you can totally jump on some of these bugs. I'm very happy to review any changes that you might have. Also, if you're interested in learning the spec, there's lots of folks in the chat right now who are from V8, and they've been doing a really great series of documentation. Maria Hulte has been writing this great series on how to read the ECMAScript specification. So if you want something that takes a slightly different approach than this stream, which just walks you through the spec, that's a really great resource. And this will be focused on going from JavaScript into the spec and then seeing how that gets implemented in SpiderMonkey. Someone asks, did I learn from Mike? I have watched his streams. I don't know if I learned anything. I also watched Suze Hinton's streams. And I was like, cool, I can probably do this. It was way more nerve-wracking than I thought it would be. Thank you so much for watching and joining me today. Bye, everybody.